Yes. Okay.
Yeah, can you see my PowerPoint?
Yes. Very clear.
Okay, so can I start for my talk? I wait until 3 o'clock.
Yes.
Can I start to talk or I wait until 3 o'clock?
Yes, of course. Yes, you can.
Okay, boleh start dah. Tak payah tunggu pukul 3.
Yeah.
Okay, so a very good afternoon to all the participants and viewer of my talk today. My name is Dr. Saratha Sathasivam and I'm from University of Sains Malaysia from main campus Penang. Okay, I would like to thanks for the organizer for giving me the opportunity to share my experience and my research on neural networks. I have been in this field for nearly 18 years and I have published few papers, handful of papers related to artificial intelligence and also I'm still working on it. I have postgraduate students also who is continuing my steps in Neuro Symbolic integrations. So today I'm giving a talk regarding how to integrate artificial intelligence with logic programming in order to create neuro-symbolic integration, which is a new paradigm. This is because, as far as we know, artificial intelligence, especially neural network, is a black box model. We know what is the input, we know the output, but we don't know what is happening or hidden trend, what is happening in the hidden neurons. So a lot of researchers has come out with so many ideas and methods how to unearth this relationship. One of the way they have suggested is by using logic programming. So in my work, I integrate neural networks with logic programming under neurosymbolic integration. This has become the stepstone for my research for the years, and today I will discuss a part of my work which is with mean field theory. So my topic today will be optimizations of neurosymbolic integration assimilating with mean field theory. So this is the outline of the talk which I would like to cover today. Basically, it's about neural networks and about logic programming. We will see what is the introductions of these two paradigma and what is the advantage and disadvantage of these two paradigma until we come out with an idea of integrating these two paradigma in neurosymbolic integrations. And for me, in neural network, I'm working with Hopfield Network. Okay, and in this talk, I will explain how we can use Boltzmann machine hyperbolic tangent activation functions in modifying mean field theory, which was proposed by Pattersons and Andersons in 1988 in doing neurosymbolic integrations, and finally usage of agent-based modeling. Okay, if we see neurons will can have two type of different problems in spin. One is flip spin and one is ferro spin. Flip spins mean the spins is getting far from each other, or ferro means the spin showing the same type of spin direction. You see, both also upward. This is because of the strong magnetic field which can happen in the neurosymbolic neural networks. Okay, because each neuron have two spins, right? One is upward and downward. This is something awkward. Okay, so we can use high energy magnetic field to repair the spin directions, or we can use high temperature. The concept of high temperature is used in Boltzmann machine, where we use higher temperature to repair the direction of the spin in neural networks. So this is the basic idea of the proposed mean field theory. Okay, so here we have the neurons and we already adjust the neuron. the neuron will spin and then relax until it reach global solution that we want. But sometimes it won't end up in global solution. It will end up in local solution. On that time, we need to do something so that the neurons we can push to rest in global solution. Okay? So logic programming on a Hopfield. Actually, J.J. Hopfield has created this Hopfield neural network, and we have done a lot of studies on how to integrate logic programming in Hopfield neural network. This one we did by deriving a learning algorithm which have time-consuming stochastic measurements of correlations. We replace it by solution to determine the mean field theory equations. We play with the energy functions known as Lyapunov energy functions. High temperature are used together with simulated analytics to push the local solution to global solutions. Okay. This is neural networks. It's an information processing paradigm that is inspired by the way such as our neurons process information in our brain. For example, if we go and touch a hot kettle, what we will be doing immediately? We will pull out the hand. Why we do it immediately? This is a very quick act, right? This is how fast the impulse or the information is being processed in our brain. So neural network also have a high number of interconnected processing elements which operates in parallel. So this neural network is recommended. One of the uses for optimizations problems and pattern reconstruction or constant addressable memory type of problems. That means even though I present and corrupted images to the network have the capability to restructure the image and map it to the nearest image. So this is what happened for our thumbprint. For example, if you go for bank, they'll ask you to take your thumbprint, right? But sometimes, if your thumbprint have some dirt, some oil, and so on, the reader cannot read it properly, right? But what happened by the using of AI or in the technology, the missing images or portions of your thumbprint will be reconstructed and matched to the database. So that is how the matching of thumbprint is done in bank, in passport office, and during your voting and so on. This is example of image reconstruction. You see, this is the original image, but what we have a degraded, that means mixing pixel or missing portion of the images, but the network still can reconstruct it back and match to the nearest original map. Okay. So neural network. This is an example of a neural network which consists of three main layers: input, hidden, and output layer. When we present the input signal to the input layer, it will be propagated towards forward the network. That's why this is known as feed-forward neural network. Okay, there are two types of neural network: feed-forward and feedback neural networks. Example of feed-forward is single-layer perceptron, multi-layer perceptron, and RBF network. Meanwhile, feedback network example is competitive networks, coherent self-organizing map, Hopfield network, ART or adaptive resonance theory models. Okay, so we can see there are a lot of applications of neural networks in handwriting recognitions, traveling salesman problem. Traveling salesman problem, for example, a salesman need to visit 10 different cities in a shortest time. So he can use neural network optimizations to find what is the shortest path he can travel in order to visit 10 towns in a minimum time. This one usually we use meta-heuristic or optimization methods to solve like this type of problems. And then we have image compression and stock exchange. We can predict, for example, forex, gold market, and so on. So we can have a look at advantages and disadvantages of artificial intelligence. It can process speed and it do not need an appropriate knowledge or background of the model. And it is robust. Even though we have some missing data, it still can deliver us an output. But the disadvantage is when the data get larger, the networks will be oscillating or will stuck into complexity issues. So sometimes they are not scalable. For example, if you want the network to do a certain task, it's difficult to extend to another task without retrain the neural network. So if we train the neural network to solve a problem, it can just be solved for a problem. If I want to solve for B problem, I need to retrain the network again. So on the other hand, logic programming. It is consists of problem clauses and activated by an initial goal statements. It describes the relationship among propositions and between assumptions and conclusions. This, for example, one day you go out from the house, you see the grass gets wet. So there are some possibilities on how the grass can get wet. One, some people pour the water, or maybe it rains a day before, and so on. So we want to see all the consequences. For example, consequences here means rain yesterday, somebody pour water, we call the consequences. We gather the consequences to see what is the output. Okay. So the advantage of this logic programming is this is very easy to write and to understand the logic. Even easy identification can of the mistakes by non-computer person. When you got the logical rule, is for person who are not good in computer algorithms and so on. If they go through the algorithms, they can detect the problem. But the disadvantage is for logic programming, it always involves programming languages. So it's difficult for person who don't know programming to carry out. It's bit time consuming, and when it comes to bigger data, you need bigger skills to handle it. So this is what it means. We are going to integrate neural networks, how our human's brain work with logic programming. Okay? These two are integrated in neuro symbolic interpretations. Okay. This is what I was telling about neural symbolic integration. This is the type of neural networks that I'm working particularly, Hopfield network. Not only Hopfield network, I also work with RBF network, also radial basis function neural network. Okay, so for today, I will be focusing on Hopfield network. Hopfield network is an associative memory and is an important resource for intelligent behavior. An example of associative memory, and it has no hidden neurons. Hopfield networks no hidden neurons, but still got energy function known as energy functions. This is a fully interconnected neural network, but has no self connections. Okay. The advantage of neural Hopfield network are it has distributed and asynchronous control. Asynchronous control means just one neuron is being updated in one cycle. Okay, and it's a content and traceable memory type of network. And it has fault tolerance. That means even though there are some missing data, the network still can perform. Okay, this is example of Hopfield network because Hopfield network is always being connected with pattern recognition problems and optimizations problem. This is an example of an pattern recognition problem, face image reconstruction. You see here, we just have a few pixels only, but Hopfield network have the capability to reconstruct the face. Okay, this diagram shows some of the power of Hopfield network in reconstructions of images. Okay, This logic programming in Hopfield Network was proposed by Pro 1 Abdullah method, uh, where we firstly we put all the neurons to relax, start from tabula rasa or initial connection strength goes to 0. And then we let the networks to interact with neurons to interact with each other. Then we will translate the given logic program. We translate the clauses into logic programming into basic Boolean algebraic form before identifying a neuron to each ground neuron. Then after that, we let it to interact until the neurons can reach an energy minimum, and then we will confirm whether the state that it reached is a global state or a local state. Okay, so Boltzmann machine is used to push the neurons which has relaxed in local solution to global solutions. This Boltzmann machine will be using temperature, parameter probabilistic distributions of temperature to push the neurons which stuck in local to global solutions. This is an example of Boltzmann machines, and this is the equations of Boltzmann machines. This is the probability of the neuron states, and you can see here the probability is influenced by the temperature. So when the temperature is high, the neurons will have more energy that it can have the energy to jump the energy barrier from local solution to global solutions. Okay, another thing that is hyperbolic tangent activation function. If we see logic programming and neural networks basically was using sigmoid functions, but we have some problem in sigmoid activation functions because it's a non-derivative functions and it intends to be slowed down in the output when the networks get larger. So researchers have recommended the usage of hyperbolic tangent activation functions to enhance the capabilities of Hopfield network. So this is the output and the input of hyperbolic tangent activation functions. It uses this hyperbolic function, which is easier for derivative type of functions. So here is the difference between hyperbolics and maculate peak function, and you can see that hyperbolic is more stable if compared with maculate peaks, and it is more bounded type of functions. Okay, so if you look at mean field theory, it's actually the integrations of a Boltzmann machine and hyperbolic tangent activation functions in solving optimizations and pattern recognition type of problem. This mean field theory was proposed by Patterson and Anderson in 1988. Okay, this is the algorithms involved in mean field theory, where we have two type of probability, positive one or negative one for the states. So what we do, we find the probability, we increase the probability of the neurons to rest in local solution by playing with the temperature, and then also we use tangent hyperbolic functions. The neurons now, the state of the neuron now is the important thing. We take the average out to reduce the fluctuation error that can occur. So if you see one neuron, if you take one neuron and add up, the probability of getting error is higher. But in this case, what we are doing is we average out the error. So when we average out the error, the cumulative error will become reduced. Okay, that is one of the advantage of mean field theory. Few persons have worked out with the mean field theory in their work, and here I have listed down some of the very noticeable work related to mean field theory. Okay, recently I and my students also have worked with it. Previously, what I showed you all was Horn process, just involved 3 neurons only. Then we extend applications of mean field theory for 2 set problems. And now we also have completed with 3 set problems. So this is a flow chart on showing how these 2 set can be used with mean field theory in upgrading the performance of neurosymbolic integrations. And then we use the simulation model by using C program. Even I can use MATLAB, Mathematica, or anything which I'm convenient with. And then I compare the performance of mean field theory Hopfield neural network 2 set with a normal HNN network. So these are the parameters which I used, and the parameters here I choose by try and error. Okay, this is the graph that I obtained, and obviously I can see that the performance of mean field theory integrated with Hopfield neural network outperform the classic model. Okay, this one is the root mean square error. I measure the 5 types of error: RMSE, root mean square error; SSE, sum squared error; and then a squared Bayesian criteria. And then I also use absolute error to see what are the output. And in all my output, I can see that MFT outperform HNN. Okay, in the terms of CPU also, this one MFT is better than HNN. So now we see agent-based modeling. So long we are using C program, MATLAB, Mathematica, all this is two-dimensional problem. When it comes to agent-based modeling, this one use NetLogo, which have Java integrated platform. The model is more three-dimensional, it's user-friendly. I can see the movement of the neurons, how the neurons are linked with each other. This output is more interactive. Okay, so this NetLogo is actually using Java language and can be viewed in 2 dimension or 3 dimension. This is user friendly because we can use buttons, sliders, switches, choosers, and so on to make it more interactive. This is example of the screenshots which I get by using agent-based modeling. This is something new, and usually agent-based modeling is used for social phenomena. For neural network, we are still venturing into it. Okay, here is a screenshot of the programming part by using NetLogo, where you see we have interactive. Sometimes I can put a box and I can put some diagrams to show the interactive in 3-dimensional. Okay. So this algorithm also, we tried with some simulated and real life problems. For example, students' exam marks and so on. In all, the mean field theory outperformed BOLTZMANN and hyperbolic methods. So this is animals in zoo data set. Also, I can see mean field theory outperform the other 2 algorithms. So basically, mean field theory is better than the primitive type of learning algorithm which have been used to train Hopfield networks in doing logic programming. So the development of agent-based modeling also been recommended in order to enhance the capability of doing neurosymbolic integrations. Okay, that's all from me.
Well, thank you, Dr. Saratha, for the nice presentation. Then I hope that students can get more information about one kind of algorithm from AI. There is a question from the student here that what kind of programming language can we learn to implement the NN neural network algorithm?
All the program language can be used to implement neural networks. There is no limitations. You can use C, Java, MATLAB, Mathematica. The important thing, use a program which you are convenient with.
Okay, yes. Okay, for next question here that student said that if we want to research related to weak detection robots using vision, is that can we use NN or neural network algorithm to create the robot detection?
Definitely, that is related with fuzzy logic, fuzzy sensors, and so on. Okay, that is another different domain of machine learning in neural networks.
Okay, so we need to learn another algorithm, right? For this kind of research.
We
Okay,
use fuzzy
Dr.
sensors.
Oh, fuzzy sciences. Okay. So I hope that the student can write down and have a note for the material today, right? Because it can be your idea for the next research. Maybe for the graduation thesis later, you can create some kind of implementation by using neural network algorithm or the algorithm that already explained by Dr. Saratha. Okay, is there? Oh, I think there is. Oh, just it for the question. Okay, doctor, thank you so much for the time today
Okay, thank
because
you.
yeah, you give the very nice presentation that the new information and new knowledge for the students in UMTAS.
Okay. Thank you for the invitation. Any students have problems, they can email me at saratha@usm.my.
Okay, at saratha@usm.my.
Dot my. Yes.
Okay. For the student, maybe you can write down also if later you can have the question. Don't hesitate to contact by email. Okay. Okay, I think because the time is also have the limits for today, and we already have the very grateful and very inspired from our two speakers today. And because this is the last session, so before we close the event for the presentation from each speaker, we would like to take a picture together from Dr. Saratha and also Dr. Aziz. And all of the participants, maybe you also can open the camera to take a picture together. I try to take a picture, and so for this is for the documentation for our event activity today. Okay, I'd like to take a picture for our documentation. 1, 2, 3. Wait a minute. Once more. 1, 2, 3. Okay, thank you so much for the time for today. Thank you for Dr. Saratha that already present today. And all the students, don't forget your notes and fill out the assignment later from your lecturer in UMTAS. And again, because this is the last session, so I'd like to close our activity for today. Thank you so much to Dr. Aziz and Dr. Saratha for today for the very great presentation. And we hope that we can meet you again in another occasion for another knowledge and information. I think this is the last from us. And thank you from the International Office Universitas Muhammadiyah Tasikmalaya. So the last, wabillahi taufiq wa hidayah. Wassalamualaikum warahmatullahi wabarakatuh. Thank you so much for today, and you can leave the meeting.